Hi, my name is Cecil C. from SingaporeStudent.com. Today I would like to explain a little bit about Vsepr theory for chemistry or GC. As we know, Vsepr stands for valence shell electron pair repulsion theory. Today I want to explain a little bit a simple one of the simple Vsepr shapes. So today we are covering three shapes. These three shapes are tetrahedral, trigonopyramidal, and band. And I'm going to explain how you can come out to the conclusion of how you can conclude the shape of a certain molecule. In this example, we are going to use CH4 or methane molecule. Methane is CH4, one of the simple organic substance. The shape will be tetrahedral. Later, we are going to learn how we can tell that CH4 is a tetrahedral. The next one is NH3. NH3 is ammonia molecule, and the ammonia molecule will have a shape of trigonopyramidal. Again, we are going to learn how to draw dot and cross diagram and tell how we can tell that the shape is trigonopyramidal. And the last one is the shape is called band, and the example that we use today is H2O. Now we are going to learn how to draw the dot and cross diagram today. Now the question might ask you to tell the shape of a certain molecule, and to be able to answer that, you need to be able to draw the dot and cross diagram. Now it's a bit complicated. The example that I'm using here are simple examples, so later in the next presentation I might give you a more complicated one. But for this simple one, what must we do? So usually I ask my students to draw the dot and cross diagram for each individual atoms. Like this example, if you are asked to draw dot and cross diagram of a methane molecule, so usually I ask the students to draw 1 carbon atom and 4 hydrogen atom, and there will be unpaired electron. So what we can do is we mark the unpaired electron. Carbon have 4 and hydrogen have 1 each. So the number of unpaired electron is matching. We can easily tell that carbon is the central atom. So what we do, we just connect the unpaired electron between the central atom and the side atom. So this is our working. Of course, we should not show this working. Later, I'll tell you how to present the answer. And what to do? Once we make the connection here, we just combine. So the bond pair between the central atom and the side atom is going to be a dot cross, each of them. How to present the answer? Very simple. You draw the dot cross diagram without the color, right? Without the color. The next question they ask after you know the number of lone pair and bond pair is they ask you to draw the shape. And to be able to do that, you just count how many lone pair and bond pair are there. The bond pair are marked with green color, so we have 4 bond pair and 0 lone pair. You can just memorize from the list of Vsepr shapes. If you have 0 lone pair and 4 bond pair, then the shape will be tetrahedral. Sometimes the question asks you about electron geometry. What they mean by electron geometry is, it simply means that if you count the shape of the lone pair, electron geometry simply means that you take into account the lone pair. So in this case, the electron geometry will be tetrahedral for all of them. As long as the number of lone pair and bond pair is 4, then the shape will be, the electron geometry shape will be 4. In this case, 4 plus 0 is 4, right? So if they ask you to draw the shape, no problem. Very simple. Just draw the bond pair between central atom and the side atom. Yes. So that's how we can come out with the conclusion that CH4 is a tetrahedral. It's rather difficult to explain this chapter without looking at the 3D shape. So I purchased this Vsepr Models. This is a model of CH4 molecule. The yellow one is the carbon atom. These white spheres are hydrogen, and they are connected with bond pair each. So you have 4 bond pair and 0 lone pair, and the shape will be tetrahedral. So usually when the students come to my lesson, I ask them to make this model ourselves. This one is detachable, so the student can learn how to can learn about this Vsepr. Another type of model is the simpler one. Yes, this model is a smaller model, but it means the same thing. This is a model of CH4.